Hey there, it's Jason Gorman from Codemanship with a video all about legacy code in C#. So first of all, it'd probably be a good idea to sort of qualify what we mean by legacy code. And I really like the definition in Michael Feather's excellent book, which is called Working Effectively with Legacy Code. And he essentially defines legacy code as code that does not have automated tests, that doesn't have fast-running tests. And I think there's some very clear thinking there. One of the biggest factors in the cost and the risk in changing code is how long it would take us to find out that we've broken it, because the cost of fixing bugs rises exponentially the longer they go undetected. So ideally, if we make a change to some code, we'd like to know straight away, and that kind of implies that we can test it very, very quickly. So code that does not have fast-running automated tests tends to be expensive and risky to change. It's very easy to break it and not realize you've broken it. And companies who rely on legacy code, whether it's a product that they sell or whether it's an internal system that they want to change, are in the unenviable position of not wanting to risk making that change because it's either too expensive or it's too risky to change the system, because they might break it and not know. So there are many, many businesses out there and many, many users, millions and millions and millions of users who are relying on software that's been in production for a long time, maybe, or maybe it's the first release. It doesn't really matter how old the software is. What matters is how difficult it would be to change, how expensive it would be to make changes to it. So tests are a big factor. So if we inherit a legacy system as developers, ideally, we'd want to get automated tests around it. And in Michael's book, he outlines a process that I'm going to give you a sort of a potted tour of. There's obviously a lot more to it, as you'll discover when you read Michael's book. But it's a sort of an algorithm, if you like, for making changes to legacy code safely. And as you might suspect, the emphasis of that process really is on getting tests around the code that we want to change so that it's safe to make that change, and also so that it's safe to refactor that code. So let's take a look at some legacy code that doesn't have automated tests, fast-running tests. Well, this is the code that I showed you if you watched the previous video on the test pyramid. Essentially, it was exactly this problem. We had some code for pricing movie rentals based on the IMDb rating of that movie. This has a direct external dependency, which is stopping us from testing it in a fast-running kind of unit test, because it's actually going to hit a web service. And I've actually rigged up a little sort of test harness, if you like, with this console application here. So I can feed it IMDb movie IDs, and it will fetch that information from the online API and do the pricing calculation and display the results. And what I've done is I've kind of got automated tests, sort of. I've written a little batch file here that builds my solution and then uses this command line, this console application, to just test 3 different cases: a high-rated movie, an average movie, and a turkey, a stinker, basically, to make sure that the prices are correct. So what I'm going to do is I'm just going to demonstrate, and this is sort of retreading what we covered in the testing pyramid demonstration, but let's just go to our test console folder and run our little batch file. That's it's going to build this, and then it's going to use the console app to run those 3 test cases for us. And I'm going to inspect the results using my eyes. There we go. So it's built, and now it's testing it. So we got, there's a great movie, The Abyss. Its rating is above 7, and therefore we charge £4.95 for that. That is correct. Manos, The Hands of Fate is one of the worst movies in the world, has one of the lowest IMDb ratings. I'm dying to see it now. I can't wait to see it. So we knock £1 off the price for that, so that's correct. And finally, Daddy Daycare is a pretty average movie. It's watchable, I suppose. So we would charge our standard price of £3.95. So all our test cases are correct. And I'm also paying a little attention to the start and end time of this test execution cycle that we've gone through here. to see that it's taken exactly 1 second to run 3 test cases. So you could imagine for a much larger application with thousands of tests, well, we'd be in a bit of trouble there. It would be a very, very slow process because these are not fast running tests. In many cases, we might even be forced to test it manually. So for many applications, teams, basically, they have to build the app, deploy it to a web server, open a browser, click the buttons, and et cetera, to see if it still works. So it's a very slow process to retest the software. And that's where we have this problem, which is the slower our tests run, the slower our test cycles are, the harder it's going to be to test it frequently, and therefore more bugs are going to slip through. Basically, we're going to end up with broken code, and we're going to be spending a lot of our time fixing bugs. So change to the software becomes risky and it becomes expensive. Very often it becomes so expensive that people stop asking for changes. There are many teams out there working with legacy code who are just basically fixing bugs, and that's all they do. And when, of course, because their tests are slow, maybe they're testing manually, as they fix each bug, they're also probably introducing new bugs as well. So it's a bit of a cycle of pain there that we're going through. Now let's imagine that we're asked to make a change to this pricing logic. We'd like to do this safely. So being good code crafters, we'd say, well, of course, we're going to write some tests for that. But there is something getting in the way here. As we saw in the video on the test pyramid, what's getting in the way here, and it's usually the reason why we don't have fast running automated tests for our code, is there's this direct external dependency embedded in with the pricing logic. So this module here is breaking the single responsibility principle. It's doing more than one thing, and one of the things it's doing involves connecting to an external web service. And therefore, that's why these tests all run slow. So here's the process that Michael talks about in his book for changing legacy code. What we don't do is we don't just start refactoring legacy code willy-nilly. The results of that are always very disappointing, and customers get very annoyed because we've essentially stopped development, stopped fixing bugs or whatever we were doing, and we're focusing on this sort of speculative refactoring. So don't speculate on what you need to change to make the legacy code more unit testable. Instead, identify which code needs to change. So the customer says we want to change the pricing logic, and we say okie dokie. And then we take a look at the code and we identify what Michael calls the change point. That's the part of the code that we need to change to give the customer what they want. And in this case, the change point is here. So we've identified where the code is that needs to change. So that's step number 1 in Michael's process. Step number 2 then is to identify what Michael calls the inflection points. Some people call them the test points. These are the classes or the interfaces around which we would wish to write automated tests to reassure ourselves that our code still works. So what we're saying is at these interfaces or at these classes, if we were to break this code, it would show up there. There would be a problem there. But we're also looking for interfaces that are unlikely to change, sort of stable interfaces, so that when we've written our tests, we're not going to be constantly rewriting them as we refactor the internal design. So it's probably not a great idea to always be writing tests directly around the change point. You want to leave a bit of wiggle room inside of which there's space to refactor and change the internal design. So rather than writing a test for the pricer in this case, what I've done with my little test program here, as you'll see, is I've written tests for this rental object that uses the pricer. So if we take a look at rental here, so it's using the price method inside here. And if this were to break, if we were to break this price method, it would show up here. This would be wrong. So, and we also think that this rental class is going to remain pretty stable. We're not planning on changing the interface of rental really very much. So we're going to identify rental as our inflection point here. And you may in the real piece of software have multiple inflection points, multiple places where you think, well, if we were to break the code, it would show up there. That would break that feature as well. So you need to decide. So you're kind of striking a balance here between not wanting to essentially write a whole bunch of front-end tests for the thing, although sometimes that might be necessary. So you want to get closer to the change point, but you don't necessarily want to be directly testing the change point because you want to leave that wiggle room so writing tests around an interface that's going to remain relatively stable and leaving plenty of room behind that to refactor and improve the design. So there we go. We've identified the change point, that's the pricer. We've identified our inflection or test point, that's rental, that's where we want to write these tests. And what we need to do next is we need to break the dependencies that are stopping us from doing that. So we want to refactor this pricer class so that it's only doing the calculation, and we're going to essentially create a separate object. We're going to let's extract all of this code here into a separate object that does the job of fetching the IMDb movie information. And that will be dependency injected into the pricer from the outside so that we can stub this and write unit tests with hard-coded IMDb ratings. Okay, now, here's the sort of catch-22. This is a bit of a chicken and egg kind of situation that we're in now. I would like to refactor this class, but it's not necessarily very safe to do that without fast-running automated tests. So this refactoring is going to be a little bit dicey, and we're going to have to be super, super disciplined here. Now, there are people who say, oh, well, if you're using the automated refactorings, for example, in Rider or ReSharper, then you don't need to retest the code because those automated refactorings are guaranteed not to break your code. Well, I've got some bad news for you. That is not necessarily the case. First of all, you've really got to know those refactoring tools very well. Sometimes you may select options that make your code go awry, as it were. So we're kind of at the mercy of user error here. But also, I'll be frank here, some of these automated refactorings have, how should we call them, quirks. They're not bugs, they're quirks. And they can break your code, and on a regular basis, they do break my code. So I don't necessarily put all of my faith in that theory. I think, and this is my habit, I think it's important to retest anyway, even if you're testing it manually. Now, I've got a batch file, so it's not going to be too painful in this case. So let's start doing some refactorings. First of all, let's extract a method. For this, let's call it fetch IMDb movie. Okay, and that just takes the IMDb ID. So that's our first step, and it wants to make, no, actually, I'm going to, here we go, here's the thing. This is a static method, yes? And I'm not a big fan of static methods, and this is going to demonstrate why, because it's very difficult to dependency inject a static method. I suppose you could dependency inject a method pointer, but so the first thing I'm actually going to do is I'm going to solve a little problem here by making this non-static. Now, there is no automated way that I could find to do this in Rider, so we're just going to do it the old-fashioned way, which is make it non-static in the source, in the declaration there, and then create a new instance of it where it's being used. And that's really relatively easy to do because we've only got the one of them, the one reference. Now that I've done that refactoring, I said that we need to be super, super disciplined. So I'm actually going to build and test this again. So we're waiting for it to build. And there go our tests. And I'm inspecting by eye the results, so that looks okay. So I'm actually testing it, even though testing it is a pain in the you-know-what. I think it's important on a regular basis, even when you're testing manually, to keep testing the code. Maybe not for every single refactoring, but on a regular basis. Because the number of times where I've sort of been merrily refactoring using the automated tools, and I've done a bunch of refactorings, and then I've run the tests, or I've tested it manually, and then I've realized that I've broken it, and I'm not quite sure where I broke it, or how I broke it. So still take those baby steps. You need to be super, super cautious. Believe me, it is worth it. Okay, so that's looking good, which means we can go back to the pricer now, and we can extract a method that doesn't need to be static. Let's take this whole thing here that fetches that object, and we're going to call that method fetch IMDb movie. Okay, and now we can make it an instance method. I do like instance methods. And off we go. And again, we've just done a refactoring, so we're going to build and test it again. Now, if you're watching this thinking, oh, this is so boring, Jason, just watching the build and test thing. Well, that's why it's important to get fast-running tests in place. Now, imagine there were thousands of those tests. Dear, oh dear. Okay, now that we've done that, we can do a little trick here, a little magic trick. What I'm going to do is I'm going to use a refactoring called transform parameters. And what that's going to do, that allows me to select parameters of this method and turn them into a field of an object that's going to be passed in. Let's call this IMDb API. So we're going to create an object that has an IMDb ID field, and that's going to be passed in, as you'll see. And you'll see why I'm doing this in a minute. This is one of the cool ways of discovering objects in your design. And again, we build it and test it. Now, the reason I've added a build step, by the way, to this test thing is because I kept forgetting to build it before I ran the tests. So whenever you get into those kind of situations, automation is your friend. That's why automated builds are so very useful and valuable, worth investing in, even if it's just for a temporary batch script. Now that I've done that, what I can do is I can move this instance method to that object. A little bit of magic here. Let's do that. And here's where the tool tries to stop me from breaking my own code. So it's private. It's going to have to extend those access rights. Okay, and again, build it and test it. So I'm being super disciplined here. And even if I was having to literally build it, deploy it to a web server and click buttons myself, I would still do it on a regular basis. Thou shalt not break stuff that was working. I was going to use another word there. Okay, so now we've got a situation where we have an object that's doing the work. So we've separated the concerns, but it is still a hard-coded dependency because Pricer knows what kind of implementation it's talking to. It's actually instantiating the object itself, so it knows the class. We would like to change that and have it not know the class. So what I'd like to do is I'd like to make this a parameter of this method. So let's do that. And last time I clicked that, something went badly wrong, so I'm not going to do that. Okay. And let's retest. So now it's being passed in. So it doesn't necessarily need to know yet what implementation. If we were to extend IMDb API and pass in a subclass, we could potentially do that. But let's make it totally substitutable now. Let's go into our IMDb API class. Now, I think probably this no longer belongs here. So let's move this to another file. So I'm going to do a couple of refactorings here before I retest. I'm going to do this in a couple of steps. And what I want to do is I want to extract an interface for this. So let's call it iMovie info. Oh no, iMovie API should do it. And we're going to give it that method. Let's put it in its own file. I'm going to add that to Git. That's a good idea. And of course, in the real world, I would be committing this very frequently as well. That would be also a very good idea. Seatbelts for programmers. Okay, so if we take a look now inside the Pricer, we can change this to iMovie API with no ill effects. Now let's rebuild and retest. And that allows me to change the signature of this so that we only need to pass in the API. Okay. And rebuild and test. So I'm being very cautious here. So our goal here was to make it so that we could use this without actually binding to an implementation. So we could replace this with a stub that returns a hard-coded movie rating for our unit test that we want to write. Now then, let's just take a look at rental. So this is our inflection point. This is the thing we want to test. which means that this now needs to be injected in. We can actually put the whole thing in, I think, as so let's introduce that as a parameter. Okay, what it's going to do, so this has broken some stuff here, but that's fine, because take a look here, we need to make that public. So like I said, just because it's automated refactoring doesn't necessarily mean in actual fact what we want is for that to be swappable. So we're going to make that public. Okay. And hopefully, so there's a bunch of stuff going on here because these things are now being referenced inside our program. If we take a look there, they need to be made public from the other project. Okay, let's make sure that we're good to go. So we are in a position now where rather than passing in an instance of IMDb API, the thing that actually connects to the web service, what we could do instead is we could pass in a stub version of that that just returns a hard-coded rating. So it should be possible now for us to create a unit test project for movie rentals and write some real end unit tests, for example, that run much faster than our sort of batch file tests, our integration tests that we had before. So I'm going to pause the video here and I'm going to write some unit tests and we'll take a look at those, and that will complete the fourth step of Michael's process. So remember the steps so far. Number one, identify the change points. What parts of the code will we need to change? Then identify the inflection or the test points. Where would we want to write tests around stable, sort of unchanging interfaces to reassure us that we haven't broken the code as we've made our changes. Then we break any dependencies that are stopping us from writing unit tests, stopping us from stubbing and mocking if we need to for those external dependencies. And then we write the test. That's step number 4. So that's what I'm going to do now. So I'll just pause the video. Okay, so I've written some end unit tests that check that the prices for our rentals are calculated correctly. And as you'll see, what I've done is I've created a stub class here where we can fix the movie ratings specifically for each of those tests. Let's just take a look at that stub down there. And that allows us to test our pricing logic without actually connecting to the web service. And as you can see down at the bottom here in my little end unit test runner window here, the test execution time has gone down from a second to 13 milliseconds, most of which I suspect will be the time that it takes to actually build, spin up the environment, if you like. So the tests run very, very quickly now. And that makes the going much easier as we move forward. It's now much easier for us to make the change that we want to make. In this case, the change we've been asked to make is to add a new classification of movie, which is a classic. The classic movies have a rating of more than 8. So a good movie has, a premium movie has a rating of more than 7, but a classic movie has a rating of more than 8. So let's, in a nice test-driven way now, because we can do that, let's write a failing test for our classic movie. So we're now in very comfortable territory. And we're saying the price of that should be £5.95, not £4.95 like a premium movie, but £5.95. So let's imagine we have our rental. Let's ask for the price, and now let's work backwards from there. So let's create a rental. And in terms of the IMDb ID of the movie and the name of the member who's renting it, it doesn't matter. This test is only about one thing, which is the rating. So let's create a stub with a rating of, we say more than 8, so let's make it 8.1. And what we're saying is that should have, oops, too many parentheses there. Okay. So when I can now run this test and see it fail. Let's see that test fail. There we go. So they're not matching. Let's go to our pricer and pass that test. So I guess we need to make these more exclusive. So if rating greater than 8.0, then our price we're going to add. Oh, that's actually, there's a much easier way of doing this, isn't there? So we add £1 if it's more than 8, and we also add £1 because it's more than 7, so that will actually work. I've messed up the formatting of my code here, but that's fine. Okay, so that will be the simplest thing. So we write the tests to protect the code that we're about to change, to protect the change points, and then we make the change. So the process that Michael describes in his book goes like this. First, we identify the change points. Then we identify the inflection points or the test points. Then we break any external dependencies that are stopping us from writing fast-running unit tests, that are stopping us from stubbing or mocking external dependencies. Then we write the tests. Then, in a nice, safe way, we make the change. So we've made the change nice and safely. We can be fairly confident now that we haven't broken the code, so that's another win. But also, we've added some test coverage here. We've created more unit tests here. So one change at a time, that test coverage starts to build up quite organically around the parts of the code that are changing the most. So it's a kind of a nicely targeted way of doing that. So over time, one change at a time, it gets easier and faster to retest our code. So the cost of changing the code tends to start coming down, and the risks to changing the code start falling as well. So it becomes safer and cheaper to change over time. But that's not the end of the process. We've made the change now. We've done it in a test-driven way. All of that code is covered by tests. But while we're in here, there may be some things that we would consider also refactoring, because now we've got the tests to make it easy and safe to do that. This is called the Boy Scout rule. The rule in the Boy Scouts is that you're supposed to leave the campsite cleaner than when you found it, in a better state than you found it. And the same is true of code. Now that we've got the tests here, maybe we take a bit of time to do some cleaning up. For example, I think this doesn't really belong here. So let's move that to here. So it's out of the way. And anything else here that you might consider cleaning up? Well, let's take a look inside rental. Anything here that we might think about cleaning up? Well, we might want to consider whether we'd want to be able to change the prices. So maybe rather than having the pricer created in here, maybe we might want to pass that in so that it's another swappable dependency, another sort of level of swappability there, another flex point in the design. So let's take a look and see what that might look like. Let's create a field. Let's have it initialized in the constructor, make it read-only. That's so far so good. And it's now very, very safe to do this because we've got fast running tests, so we can retest pretty quickly. And okay, so that's being set in the constructor, but maybe we want it to actually be passed in. So we add it as a parameter. Okay, and then again, we've got the same problem there. So let's make that visible. Now that I've done that, I'm getting a feeling that we're exposing rather a lot here. So we might also, okay, movie as well. Yeah, we're exposing rather a lot here. Let's just see if that builds. So I might want to consider creating a facade for rental so that we don't have to actually expose all of this. I'm not going to do that now because that might be a slightly more complex job. But the idea basically is while we're in here, we look for other problems with the maintainability of the code, how easy it is to read, we look for duplication and all that kind of stuff. And we fix some of those problems so that the going is easier for the next person who has to change this code. We just clean up a little bit while we're in there. So there's the process that Michael describes in his book. Let's just take a look at the book again. Well worth investing in. Start by identifying the change points, the parts of the code that you would wish to change. And that's in order to give the business what they've asked for. And then identify the inflection points. Where would we want to write tests, fast running unit tests, to make sure that our change hasn't broken anything. So we're looking for those interfaces around the change points where it would show up. If we broke the code, it would show up there. And we're also looking to create a little bit of wiggle room there in terms of refactoring space. Then we remove any dependencies, direct external dependencies that are stopping us from writing fast-running unit tests. So we make it possible to stub or mock those dependencies. Then we write those unit tests. Then we make the change. So we make the change easy, and then we make the easy change. And then while we're in there, we clean up a bit, basically. We leave the campsite cleaner than we found it so that the going is easier for the next person who needs to change that code. And change after change over the weeks and the months and the years, sometimes, depending on the size of the legacy code base, a legacy code base can start to turn around. The cost of changing that code and the risk of changing that code can start to come down, sometimes to a point where it's essentially not legacy code anymore and it's as easy to change as it was when we first started writing it. Although, we very rarely get into that territory, but we can certainly get into a space where the code becomes a going concern. So I've seen many businesses where business users, marketing and sales and HR and etc., they've stopped asking for changes to a system because the answer is always, oh, that's going to cost you, too expensive, too risky. And the problem there, of course, that means that if that's the software that's operating your business, you're relying on it every day to do what you do, that means that you cannot evolve and adapt how you do what you do. It's very, very difficult. So you find businesses always trying to find these complex workarounds to get around these legacy systems, but it really holds these businesses back. It can kill businesses, absolutely. I've seen some huge businesses with legacy COBOL systems, and there's no reason why you can't write unit tests for COBOL, believe me. If you go back through the videos on this site, you will find a video all about writing unit tests in COBOL. So regardless of the language, regardless of how old the software is, because I've seen software where the first release was essentially legacy code, in the sense that it was already too expensive and too risky to change. So it's not about how old the code is. It's about how difficult to change it is, and that usually means how long it will take to retest it. So the priority is to get tests around it, and that makes making those changes safer and easier. So this is very closely related to the testing pyramid. How long it takes to build and test our code is a big factor in our ability to maintain the pace of delivery and maintain the pace of innovation. And that's very closely related to the whole idea of continuous delivery and continuous integration. So all of these things, your unit tests and TDD, version control, build automation, continuous integration, continuous delivery, and legacy code, these things are all very closely related. Now, in our final video in this series, we're going to be moving slightly left of field. We're still going to be talking about continuous delivery, but we're going to be talking about a different kind of testing, a sort of non-functional testing. And that's testing that many teams do in a very ad hoc, manual way, but don't necessarily think of it as testing, and that's code reviews. Code reviews for many teams who are trying to do continuous integration and continuous delivery, because they're doing them manually, for example, with every pull request, they find that it becomes a bottleneck, and they either have to let the quality slide or sort of live with the bottleneck of waiting for another team member to read the changes to your code and comment on them. So our final video, we're going to look at how we can remove or at least reduce that bottleneck, that code review pull request bottleneck, using a practice called continuous inspection. So that's going to be the final video in the C# series. I hope this has been of some use. If you're looking forward to new videos in the series or on this channel, then ring the bell for notifications, hit the subscribe button. There's a lot more to come, not just about C#, but about codecraft in general. So stay safe, and the next video hopefully will be appearing soon.